So let's go over the basic setup and function. We have our handheld inductive heater held in place by a simple wooden holder. We have a simple reloading press, a small contact switch, and our actual control unit, which consists of an analog timer relay, a couple LEDs, a power switch. What we don't see is a power supply connected to a plug-in along with the power to the inductive heater. So very simply, with the system off, the press will come up, the brass will be placed inside the inductive heating coil, the switch closes, which signals to the relay to turn the heater on, and the relay will determine the amount of time that the heater stays on, as determined by the potentiometer knob on the front and the scale and setting and range of the relay. Very simple, as that all can be adjusted via the knob or a small screwdriver. Once the time has timed out, the relay will turn off the heater. The heater will be off, even with the brass still in position. So essentially, you'll be activating the heater for a very precise amount of time to get a consistent anneal. Then, once the brass is drawn down, the switch will open and the cycle will be able to reset. The brass will be removed with a piece of pliers, a pair of pliers that is, and the next one will be placed on. So let's power up and have a look at a quick operation. So we have the heater turned on with power, but it is actually not heating right now. We have that fan going so it stays cool. We will turn the control unit on. We have a power indicator and an output indicator. There is a power and output indicator already on the relay itself. However, I wanted some bigger ones, some brighter ones. So we'll raise the brass up. Our contact will close. We see we have output. Our heater comes on. Our heater starts heating the brass. Automatically, it'll shut off at the set time. We'll lower our brass, remove it with a pair of pliers, as it's going to be hot. There we go. We have a annealed piece of brass. This is 6.5 PRC, and that's just shy of 7 seconds. Let's repeat the process. New piece of brass. Again, rises up, hits the contact switch, turns the heater on for the specified amount of time. And there you have it. Another piece of annealed brass. Very simply, turn off the power and it will not actually activate the heater. The power switch off. Great for adjusting the switch or adjusting the coil position. Now I've made 2 adapters in order to hold and space cases. One is very simple. It just has a small island that is roughly the size of a large primer pocket. And then the second one, good for 5.56 or in a blackout. It is a pocket style, so the case will sit in and be placed in and out, and will also elevate the case past the opening of the press mouth. Now I'd say the one downside to this setup is duty cycle. Because the coil is simply air cooled, the coil will eventually get hot, and with that coil heating up, you will eventually change the amount of current flowing through it and change your anneal. So I normally do a maximum of 3 cartridges in a row, and then I let it cool down. So oftentimes when I am annealing, I'm normally doing another activity, primer pocket cleaning, case trimming, and I'll come back and forth. The next options to increase duty cycle would be to use the normally closed contacts in the relay to power a small DC fan. So when it is not actually heating, you would have an external fan helping to rapidly cool the coil. That would increase your duty cycle. Or if you wanted to go to a liquid cool setup, use the coil conductors to solder to a tube coil and have a liquid flowing through the tube coil, such as a liquid PC cooler. Again, that's if you really want to sit there and crank out brass. However, for me, it is just fine that I do 2 or 3 pieces and go on to another activity to let it cool down. So the bare minimum you'll need on the electrical side is handheld inductive heater. This one I got off of Amazon. Timer relay. This is made by IDEC. It is 12 volts. Relay base. Power supply, 12 volts. This one is 2 amps. Chances are we'll be able to get away with less. We'll find out how many amps it's actually pulling. Small contact switch to tell the position of our press, and wire. It's basic you could get away with. However, I'm going a little bit fancy, so I'm adding a couple LEDs to indicate where I am, mounting in a nice big aluminum box, putting a multi-pin connector in the back, putting a power switch on it, getting a little fancy with it. All right, let's go over system operation and the schematic. To start, we'll have our 12 volt power supply, which will be sending power to the on and off switch. From there, we will branch out to the power on LED, simply indicate our switch is turned on. We'll find ground via junction at 7, which is our common ground point that will go back to our 12 volt power supply. Then we will go to the contact switch from the on-off switch. The switch mounted on the press will close once the press is in position and the brass is in position for annealing. Then we'll go to the control coil of the relay at terminal number 2. That will close the relay, and the relay will control how much time it is closed for. We'll close 2 sets of contacts. First set of contacts, 1 and 3, will become closed, and those are the heater button wires. Essentially, that will be our input now to turn the heater on. We'll leave the 120 volt alone because that will operate the cooler. No use switching that. Yeah, it's a better system that way that we keep the cooling on instead of switching the AC side. Also, this is 12 volt rated relay. So again, that's why we're switching the button. Then we will go up. We'll be borrowing power from 8, and with 2 and 6 closed, we'll activate our LED, which again will find ground through 7. Now, an optional for added cooling is a fan on at output number 5. So essentially what will happen is a small DC fan will be directed at the coil so that when the timer has opened and is no longer annealing, it will give you additional cooling on the coil. So that way you're not cooling as it anneals, only when you're not annealing. In that case, however, you would want to pull power from just after your on-off contact switch. Because in this current setup, that wouldn't actually work because you lose power as soon as the contact switch is opened. So you'd have a weird intermittency in the fan. This is shown just basically branching off from number 2 to go to our output LED. So a quick look at our data sheet for our relay. We'll be using the D12 model, so we'll need 10.8 to 13.2 volts input. This allows us to use 12 volt LEDs and readily available 12 volt supplies you may have kicking around. We're good for 10 amps. We'll be well under that with our load. And the relay itself only draws 1.6 watts, which is 0.13 of an amp. So we don't need much of a power supply unless we are running an auxiliary cooling fan, which we'll have to factor it in. The next thing to consider is our setups. So there is 4 different cycles or modes that the relay can activate on, and what we are looking for is to set it to B. Essentially, we want the output to be determined by the relay in a specific time interval. So in this case, our operation will power off, then our press will come up, our contact will close. That'll tell the relay to change the state of the contacts. In this case, our normally open contacts will close for the allotted amount of time, and then they will open after the allotted amount of time has passed and revert to state regardless of the input state. From this point on, we're going to be following along as I assemble. So essentially, I opted for a 6-pin connector. I've put in my power pins. I'm putting in the pins for the switch and the pins for the button for the heater. Now I'm making some layout marks on the box that will be enclosing it all. I'm basically just pre-drilling here, and then I'm going to step it up to the old monster bit. And basically at this point, after that, I've marked out, laid out, and filed that to fit. Next, I'm laying out my relay base. I have traced it, marked the holes. I'm going to drill the holes for mounting. Now, I am going to use a piece of plywood as a spacer in order to space up into the lid. But in the meantime, we're going to lay out the lid. Just marking some center line marks for my indicator lights, and we will drill the holes for the indicator lights. Next, we'll take out the screws and we'll fit our lights, make sure those fit. There's one light, and here comes the second one. Boom. So for now, our connector on the inside of the box will be basically just painting it with our loose wires for wires out. I used all orange. Other colors help as well. Essentially, I've crimped that in, refit that in the filed slot, install our lock. Next, we will lay out for our power switch. This is a simple toggle switch. Drill that out. And I'm just making a small drill there in order to index, as the little washer has a little lock groove, so that way the toggle doesn't rotate on me. I'm going to fix the base. Again, I've put a plywood spacer in there, some small machine screws. Tighten those up. Install our relay. Next, I will line and mark out our relay. I basically drill the corner holes, and then I drilled a bunch of holes to kind of punch through. few more holes, use the Dremel a little bit, and then I use the file. Helps makes those corners nice and square. Once it's been filed up, then I will fit check and adjust as needed until that lid sits just right. And there it is. Next, I'll be doing the terminations. First, I'm going to my power switch and soldering on. Then I'm soldering over a few jumpers to our LEDs and the base. Get some shrink tube on there. Get that set in. Tidy up. This is definitely probably one of the most involved processes of building this. I had to figure out a few things, adjust a few things.
Solder on our switch.
Now I am soldering the wires onto our switch. This switch has 3 contacts. One of them I'll end up just chopping off and not using. That's the middle one. A pair of hemostats helps to hold things in place while you're soldering. Slide some shrink tube over that. Heat that up. And good to go. I taped the harness. I have a locking back shell on there. A little bit of a strain relief as well, makes it look nice. I also took the time to wrap this harness in split room after I wrapped it in tape. So I used just a small piece of aluminum as the mounting bracket that will go on the press. Drill it out. I got number 440 screws, machine screws, very tiny screws, and even then I actually had to drill out the switch body just ever so slightly in order to fit those tiny number 4 machine screws. Get those snugged up.
Voila.
And screw it onto our press. I over drilled the hole that mounts onto the press, so I have a little bit of leeway for adjustment. And I'm just adjusting it so it just hits the corner of the press as it's at the very top. Next, take apart the heater, expose the button wires. I'm using a Deutz DTM connector because I have a few. That way I can separate the heater from the control unit. You could also just use spade connectors or other forms of connection, but I like the connectors, so we went a little bit fancy with it. And of course, close up our heater after we're done. Plugs in, plugs off. Next, very simple plywood stand. Just kind of eyeballed where it needs to be. Cut out some notches at the diameter. Looks good. Put a spacer plate, some glue and screw, clamp that in there. My miscut piece is able to reuse as the base. And now that is good to go. A little bit of testing, figuring it out, and there she is. So let's set up our relay controls. So again, the nice thing about the analog timer relay, it's just that. Very easy to adjust. So firstly, we need to set it to B mode. That will operate the relay as a interrupt. Then we'll need to change our scale. I find that 0 to 10 works for most brass that I've done. And we need to change that to seconds because minutes would have some pretty hot lump of brass. And again, as we need. We can easily turn up or turn down as per our requirements for annealing. Great for your little differences, say brass manufacturer to brass manufacturer, or case size in general. Even coil size will affect how much time you need. So now we are ready to rock and roll.